The Ergoson is a CO2, H2O open-path gas analyzer with an integrated three-dimensional sonic anemometer. The Ergoson is the core instrument in a Campbell Scientific CO2, H2O open-path Eddy-Covariance Flux station. This video demonstrates how to properly install a typical station. The station will consist of a tripod, horizontal mounting arm, the Ergoson temperature sensor, a standalone temperature and humidity sensor, an EC100, a fiberglass enclosure housing the power supply, and a fiberglass enclosure containing the data logger. Assembling the CO2, H2O open-path Eddy-Covariance station requires the following tools: a 7/16 inch wrench, a 1/2 inch wrench, a 9/16 inch wrench, a 6-inch adjustable wrench with a 1-inch maximum jaw capacity, a flathead screwdriver with a 6.5mm blade, a flathead screwdriver with a 2.5mm blade, a 3/16 inch Allen wrench hex key, a tape measure with metric and English units, with a 4.5 meter or 15-foot length, a bubble level, a sledgehammer, wire strippers, and wire cutters. These tools are not required but aid in assembling the station. A No. 1 Phillips screwdriver, needle nose pliers, a pocket knife, multi-tool, and post pounder. Begin the installation by setting up the CM110 tripod. Remove any brush and tall weeds in a 7-foot diameter, centered on where the tripod is being placed. Try to disturb the ground surface and other natural vegetation as little as possible. Stand the tripod base on its end and rotate each foot perpendicular to the leg. Extend each leg out until the spring-loaded pin engages in one of the holes on the underside of each leg. The tripod legs create three 120-degree sectors. The CM110 family of tripods have the feature where the body of the tripod can be tipped down to gain access to the top of the body for mounting sensors. The sector that the body tips down into will be referenced as the tip sector. Orient the tripod so the tip sector points into the prevailing wind direction. Remove the bolt securing the 142cm insert inside the mast. Extend the insert until the mast is the desired length, aligning the mounting holes in the mast and insert. Resecure the insert with the bolt. Place the mast in the base and align the holes in the bottom of the mast with the lower mounting holes in the base. Insert the pin through the base and mast, then secure it in place with the wire retainer. Install the locking bracket in the base by inserting the top of the bracket into the notches in the base. Then press the mounting bracket into the base while pinching the lower tabs together. Install the locking pin. Insert the end of a guy cable into the guy ring from below and slide the end into position. Repeat with the other two cables. Slide the guy ring over the top of the mast insert. If necessary, tip the mast into the tip sector to reach the top of the mast. Line the mounting holes in the guy ring up with the mounting holes in the mast insert indicated in the tripod manual. Secure the ring to the insert with a bolt, washer, and nut. Drive a ground rod into the ground below the CM110. If the ground is hard, pour 1 to 3 gallons of water on the ground to soften it. Use a ground wire to connect the CM110 base to the ground rod. Plumb the tripod by adjusting the legs with the level on the side of the mast located in the center of the tip sector, adjusting the leg opposite of the tip sector for plumb. Move the level either 90 degrees clockwise or counterclockwise from the center of the tip sector and adjust the other legs for plumb. Attach the crossarm mount to the mast to the desired height using 2 U-bolts. The crossarm will be mounted so it bisects the tip sector and is over the leg opposite of the tip sector. Attach the CM204 crossarm to the tripod body so the longer end extends 76 cm or 30 inches from the mast. Use a bubble level to ensure the crossarm is level. The long end of the crossarm will point into the prevailing wind. Attach the lightning rod to the top of the mast. Secure the 2 sides of the clamp together with bolts and nuts. Insert the lightning rod into the hole in the clamp and secure it by tightening the set screw. Attach one of the guy hooks to the lower end of a tripod leg. With the hook lever open, pull on the free end of the cable to remove any slack. This window allows a flathead screwdriver to access the wedge that anchors the cable, in case the cable doesn't move freely. Tighten the screw to secure the guy cable in place. Close the hook lever to add additional tension to the cable. Repeat with the remaining 2 guide cables. While standing in the tip sector and facing the tripod, place the EC100 mounting bracket on the right side tripod leg 30 centimeters or 12 inches from the top of the leg. Note the notches in the plate. They must be oriented facing up. Loosely tighten the mounting bracket to the leg using 2 U-bolts. Loosen the 4 bolts in the center of the mounting bracket and rotate the front portion of the bracket until it's vertical. Use a level to ensure the bracket is vertical, then fully tighten the 4 bolts and 2 U-bolts. If the EC100 mounting plate will not rotate so that the bracket is vertical, rekey the mounting plate offset of rotation. Do this by realigning the mounting plate and mounting bracket. Remove the 4 nuts and washers from the mounting plate. Remove the mounting plate from the mounting bracket and rotate the plate so the 4 bolts can be inserted at the opposite end of each slot. Reattach the washers and nuts. The bracket can now be rotated in the other direction. Loosen the 4 bolts on the back of the EC100. Slide the bolts into the notches on the EC100 mounting bracket. Fully tighten all 4 bolts. Mount the power enclosure on the leg opposite the tip sector but on the same side as the EC100 by sliding the keyhole notch in the enclosure bracket over the short bolt extending from the top of the tripod base. Slide the enclosure bracket over the enclosure tab extending from the tripod base. Place the other side of the enclosure against the tripod. Mount the data logger enclosure on the opposite side of the tripod leg as the power enclosure, so the 2 enclosures are positioned back to back. Slide a mounting bracket onto the outer enclosure bracket of both enclosures and align them with the tripod leg. Using 2 bolts, one above the tripod leg and one below the tripod leg, secure the 2 enclosures together by fully tightening both nuts. Slide the CM250 onto the end of the crossarm. Secure the CM250 to the crossarm with set screws. Attach the ergoson to the mounting bracket using the mounting bolt and pin. Fully tighten the bolt. Make sure the analyzer is vertically oriented so the label is right side up and the upper arm is directly above the lower arm. Attach the ergoson to the CM250 leveling mount with the bolt. Check to confirm the ergoson is vertical using the bubble level on top of the unit. If not, slightly loosen the bolt securing the mounting bracket to the CM250 and adjust the ergoson as needed. Then retighten the bolt. Attach the ergoson temperature sensor with the smaller radiation shield next to the tripod on the short end of the crossarm using a U-bolt, lock washers, and nuts. Now attach the Hygrove U10 temperature and humidity sensor in the larger radiation shield to the same end of the crossarm as the ergoson temperature sensor. Mount this sensor at the end of the crossarm. Begin the wiring process by routing all the wires from the ergoson and other sensors from the crossarm to the tripod mast, then down the mast to the EC100 and data logger enclosure. Allow the wires to droop below the crossarm to form a drip loop. Use zip ties to secure the wires to the crossarm and tripod mast. Locate the thicker black cable coming from the ergoson. This is the gas analyzer umbilical cable. Remove the black rubber plug from the gas analyzer port on the bottom of the EC100 enclosure. Store the plug in the mesh pocket inside the enclosure. Slide the connector on the gas analyzer cable through the open port on the EC100 enclosure and plug the connector into the EC100. Secure the connector with the thumb screws. Repeat this process for the ergoson sonic anemometer cable. Remove the rubber plug from the sonic anemometer port, slide the cable through the port opening, and plug the connector into the EC100. Secure the connector with the thumb screws. Connect the ergoson temperature sensor to the EC100 by removing the temperature connector cover from the bottom of the EC100 enclosure. Insert the sensor connector into the EC100 connector and fully tighten the connector. Connect the EC100 enclosure to earth ground using the ground lug on the bottom of the enclosure. Connect the other end of the ground wire to the CM110 base. Connect a communications cable to the EC100. SDM, USB, RS-485, and analog options are available. In this example, SDM communications are used. Remove the plug from the cable 1 or cable 2 port. Route the SDM cable through the open port and attach it to the terminals on the EC100. The green SDM data wire goes to SDM C1. The white SDM clock wire goes to SDM C2. The red or brown SDM enable wire goes to SDM C3. Both the black digital ground wire and clear shield wire are attached to G. Tighten the port. The other end of this cable is attached to the CR1000X in the data logger enclosure. The green SDM data wire goes to C5, the white SDM clock wire goes to C6, the red or brown SDM enable wire goes to C7, and the black and clear wires go to G. Connect the EC100 to power. Remove the remaining plug from the cable 1 or cable 2 port and slide the 2-wire power cable through the port. Attach the red wire to 12V and the black wire to G. Tighten the port. Connect the other end of the power cable to the SDI-12 power distribution terminal block inside the data logger enclosure. The red wire goes to the red terminal, the black wire goes to the black terminal, and the clear wire goes to the black terminal. Connect the data logger to the SDI-12 power distribution terminal block. C3 to the gray terminal block, 12V power into the red terminal block, G power into the black terminal block, and the grounding lug to the green terminal block. Route the Highgrove U10 cable into the data logger enclosure and connect it to the SDI-12 power distribution terminal block. Connect the brown power wire to the red terminal block, the white SDI-12 data wire to the gray terminal block, and the black and clear wires to the black terminal block. Connect the internal enclosure earth ground wire to the green terminal block on the SDI-12 power distribution terminal block. Connect the main enclosure to earth ground using the ground lug on the bottom of the enclosure. Connect the other end of the ground wire to the CM110 base. Provide power to the system. This is usually done by using a solar power system or a mains power system. Connect the system power cable to the SDI-12 power distribution block, 12V to the red terminal block, and G and shield to the black terminal block. In this example, the station will be powered from solar. The solar panel CM110 tripod is installed at least 50 feet downwind from the Eddy-Covariance tripod. Position the solar tripod so the tip sector is facing the equator and one leg is pointing directly away from the equator. Attach the upper solar panel bracket to the mast and the lower solar panel bracket across the two legs on either side of the tip sector. Attach the solar panel to the solar panel mount. Run the solar panel cable to the power enclosure on the Eddy-Covariance tripod and connect it to the solar input terminals on the SunSaver, the red wire to positive solar and the black wire to negative solar. Move the circuit breaker to the off or tripped position. Run the system power cable from the data logger enclosure to the power enclosure and connect its red wire to the circuit breaker and the black wire to the negative load terminal on the SunSaver. Ensure the battery is connected to the SunSaver, with the positive terminal connected to the positive battery and the negative terminal connected to the negative battery terminals on the SunSaver. Move the circuit breaker to the on or non-tripped position. The Campbell Scientific open path Eddy-Covariance system is now fully assembled and capable of returning valid measurements.